All right, everybody. Thanks for your patience. My name is Randy Jones. I'm one of the cloud platform architects here at VMware. We'll get into introductions later. Is everyone here familiar with vSphere? Been doing vSphere for a while? Anybody not familiar with vSphere? Okay, good. So we're just going to say everybody's good with vSphere. Yeah, Peter. So I have really one goal in the performance lab that I hope you take away. And that is, I hope I save you a weekend or 2 weekends from working on the weekend to try to fix a performance issue. If you get anything out of this, I hope you can save a weekend. That's my job, right? So hopefully you'll get that out of here, but we'll get started, right? So welcome to the Expert Lab Workshops. We're gonna go through an introduction. I'll tell you who I am, what I do. I'll explain how we construct the lab. We'll go through a lab experience, like what you should experience in the labs, and then we'll kind of go through the first module of this lab. This is 2409-21, which is the introduction to vSphere performance. And then I'll let you, if time permitting, you guys can go through the second module and move forward through that. So I started VMware in 2006. That's part of the reason I run the vSphere Performance Lab, because everybody else is afraid of performance. Just kidding, right? But seriously, like, I've been doing performance for a long time. Back in the old days, that's the biggest part of what we did was vSphere performance, right? How do you perform? How do you virtualize? All those things. So I was actually part of the original team that did the hands-on labs in 2007, and I've been kind of engaged ever since, right? So I've been 13, 14 years doing hands-on labs. So we've done everything from deploying the labs to 3 of our data centers worldwide: Amsterdam, Miami, and Las Vegas, and SwitchNap. Now we're actually in, I think, 11 to 12 clouds running against that, and I'll show how we're actually doing that today. It's pretty cool. Made a lot of progress over the years. And then for fun, I still like technology, but I don't really like software that much after days of VMware. So not that VMware's bad, but I like hardware as well. So I work on pinball machines and arcades. I restore those and I have about 150 machines in my barn that me and my buddies play with. So lots of fun there. So the hands-on lab. So this is not a me effort, right? So there's lots and lots of people supporting these hands-on labs. So there's folks that manage the infrastructure, there's folks that build the content, there's folks that do supporting, answering questions. There's a lot of us that support this basically year-round. So we start these labs in March, April timeframe, building out the content for you, doing testing against all the clouds, and so on. We do use vCloud Director as a front end for all these builds. So if anybody here familiar with vCloud Director, amazing tool, right? I hope, yeah, everybody's, yeah. So vCloud Director is amazing, right? So we basically are building these pods, these virtual pods, and I'll get into the build process in a second just to kind of give you an idea. And we use many of the same products. So we get into this in a little bit, but we actually, anything vSphere, vSAN related, NSX related, they're all built in what we call a megapod. And I'll explain the megapod, but it's they all kind of share this lab. So here's a great eye chart to show you the lab and how they're built, right? So this megapod actually supports a bunch of different products. What we did is to try to consolidate everybody building out a lab, because all these labs are built on virtual hardware, right? So we have physical layer, then we have, what do we say? We have 23 layer 1 VMs. So we have ESX, then we have physical ESX, right, at the layer with VCD. Then we have virtual ESX, and then we have virtual machines running on the virtual ESX hosts, right? So it's like 3 layers deep of virtual machines, right? So it's a really big lab. It's about 3 terabytes in size. So it takes us a long time to actually push that out across multiple clouds. But once we build it in this megapod, we push it one time, and then we inject like things that we need for our lab, like lab prep scripts, right? So that when you boot up, you don't see everybody's stuff in this lab. We basically unregister VMs and only register the VMs for you for this lab. So as you take other labs that have these products in them, they're using the same exact pod that we're using. In this case, everybody has their own pods, which is amazing, right? So back in the old days, everybody used laptops, and we used VMware Workstation and had a VM on there that you ran all the labs from. And then we would restart it and it would go back to the beginning and we would do it all over again. Now we can actually push these pods out, clone the pods, and have an amazing experience. So everything is live. Also to note that in these labs, even though these are going to be available online after the fact, these labs, you can use them for a lot of different things. You get them for about an hour and a half, free of charge. Go in, use the lab manual, but if there's things you want to go look at that aren't part of the lab manual, feel free. That's why they're there. Okay? Questions yet? How it's built? So the lab environment really does mimic a physical environment. So when you log into vCenter, it's all going to pretty much look like it does in a real physical VMware environment. You're going to see ESX hosts, you're going to see clusters, you're going to see VMs under those hosts. But just remember, physical layer, then you have a virtual vCenter, virtual ESX host, virtual VMs under those hosts. So this is not a lab that you would want to actually run a performance test against, right? Like, let's just call it that, because this thing is nested beyond nested. But what we've done is we've actually loaded some scripts in on some of these labs to actually give you an experience where you can actually see what you should be seeing in a physical environment, right? And hopefully we give you enough troubleshooting steps, again, to save a weekend or two minimum, right? That's my goal. What you will notice is on the ESX host, you'll see that they actually say something like VMware 7.1 or something like that in there. That's because there's no real physical hardware to say it's an HP X or a Dell this or a Lenovo that, right? So this is virtual. That's how you know it's virtual. It'll be in there in the model number. Now, this is the vSphere performance introduction, right? We originally called it best practices, but not many people were taking it because that seemed a little generic, so we changed it back to vSphere introduction to performance. But there are 3 labs. So my lab partner, Dave Morse, he basically helped us build all these labs. We had it all as one for the past 8 years. And they said, hey, you guys have now built this lab where it has 8 hours of content. Nobody can take that. So they made us break it up into 3 labs. So the first one is the introduction to vSphere performance, which we're doing today. Then we're going to have vSphere performance testing of workloads. So we'll actually load up some databases, do some applications, run some testing, show you some testing tools to check that. And then in the last one, we're going to do vSphere performance ESX. Anybody here use ESX top? Everybody, pretty much? Yep. Okay, cool. So that last one's going to really show you how to maximize your uses of ESX top, right? So just understand you can go in, we'll do some load running of like CPU, show you how you should be looking at it in ESX top. Because although you're using ESX top today, we might show you a tip or trick that will show you how to look at it in a different way, right? So keep that in mind. That's a great lab, so please take all those labs. Again, today we're going to go through Module 1. If we get time, we'll go through Module 2. We'll get as detailed as you want. So I've been here for a long time. So even if you have a question about a non-performance related question, I will help you, right? So I've been here since there were 3 VMware products. So I don't know everything, but I usually know who to go ask to find the answer. So please feel free to ask. I'll do my best to help you out, myself or Peter. Peter's in the back. And between the two of us, we have like 30 or 40 years of VMware experience, so we're good. All right, so let's begin the lab. Any questions so far? No? Okay. Let me get out of this and go into Google. Is everybody logged into 2409-21 so far? Okay, perfect. All right. I will catch up real quick. 24. Enrolled. Start. Resume this lab. Perfect. All right. So, anybody here not taken a lab before? Yep. Perfect. All right. So, I won't kill everybody with all the details, but the labs are amazing. I've been working on it a long time, so I think they're amazing. But there's a couple of things that may help you with some of the driving around of the labs, right? So if you're not familiar with the manuals, like you can get them out of the way if you want, right? You can move them out of the way. You can drop them out into a new window. You can bounce around if you like. So you can go to like page 10. You can go into the table of contents, and you can actually look at the table of contents and actually point around and see where you want to go. What I like about doing that is that some of these labs are a little long and lengthy, and you might not have 2 hours to take that lab. So keep track of where you are, make sure that everything's good, and then just go to the last part of that module, and you can jump back into your lab and keep going, right? So in this lab, let's see, and why is this all small still? There we go. All right. So let's go through the lab. So these things are set up so that if you follow along with the lab, you'll actually see what we actually want you to see, right? Now you can do other things in these labs, that's fine. During these processes though, we've kind of built it so we tell you what to click on, we tell you what you should be looking at so that you actually get the most out of the experience, right? Because what we don't want is we don't want you to go through this lab and realize that you're very frustrated because, hey, I don't know what they mean, right? So we've tried to be very detailed. If you see any problems with the lab manuals or anything, please let us know and we'll fix them. But we want to make it a great user experience for you, right? So in the lab guidance, you'll kind of see some things. Now I want to point out that in this, if you scroll down in the lab guidance, you'll see a lot of links here, right? You see all these links. I'd like you all to click all those links right now and read them all. Can't do it, right? Not possible. These lab manuals will be available online so you guys can download them. That's the whole point of this, so that you might say, oh, I've got this thing and I can't find this performance. So you can go in here and you can say, oh, well, let's look at best practices for vSphere 8. Perfect, update 1. Let's go look at, there's lots of things like advanced using NVIDIA DPUs, right? Like, so you might have questions about things you're doing, so we want to make these available as a resource for you. Right? So please feel free to log in, download the manuals, use them how you will. But that's why there's links there. Please don't think that we're going to go through all those links. All right, lab description. All right, module 1, introduction. So we'll go through, we're going to go through the vSphere basics. Oh, everybody's lab status. Everybody say green? Okay. When you're taking these from home, understand that in this lab, we knew that there was going to be 25 people here. So we do what we call pre-population of those labs. Those labs are already spun up and copied and ready to go, right? When you're at home, they might not, we always keep some available, but if there's multiple people, because I know everyone's going to be taking the performance labs, there might be multiple people taking them at the same time, so they're going to have to spin it up. So always make sure that's ready, because when we spin it up, we start booting up vCenters and all that stuff, and then we run PowerShell scripts to make sure, oh, is this running, is this running, is this running? So always keep that in mind. Make sure it says ready status when you're taking the labs. Because again, I don't want you to get frustrated thinking something doesn't work when it just didn't start up right. Very important for this lab. There's something called lab prep. So I mentioned it's a megapod. So what we do is we use this pod. So now I wanted to say, hey, I want to prep this pod for this lab, right? So we kind of force that just to make sure, A, everybody's paying attention, and B, that everybody's on the same place, right? We don't want something to have accidentally started lab 3, so we just do this. So we're going to go lab prep for performance. This is going to run, you're going to say start, and this is going to run for a bit. Probably about 30 seconds to a minute. And I'm getting ahead of the manual, but that's okay. Okay, once everybody's console is up, is everybody's already up and ready to go, or did everybody jump ahead? Yeah, I'm seeing nods. You all jumping ahead. This is instructor-led, not people-led. You're jumping ahead. That's fine. You're more than welcome to, this is your lab time, take it for what you will. Listen to my nonsense and take the lab and get something out of it. That's the important part. But once these consoles are up and running, it's going to say press enter. That tells you that everything that we wanted you to do for the lab is already set up, ready to go, good to go. Then we're going to start going into the lab and talking about vCenter. Trying to think of some things that we can talk about while this is running. So anybody here know anything about like virtual NUMA, vNUMA? No? Okay, cool. So if you have performance issues, that could be part of the problem. So I'm going to show you that. I'm going to save you a weekend. That's my goal. So basically, we're fixing that in vSphere 8. So I'm not sure what, is everybody on 7 still? Anybody below 7? Perfect. All right, anybody in 8? All right. For those of you on 8 already, we have something, and I'll bring it up here in a bit. It's called vTopology. And that's going to help out with all the vNUMA stuff and kind of fix some of those problems for you. All right, so let's get here, press enter. Okay, we're good to go. So let's go ahead and open up Firefox. We're gonna go under, I'm gonna try to be a good citizen and use the lab guide for you. So we're gonna go ahead and log in. Now there's one little tricky part here, right? Just know is if you click on here and say administrator at vSphere.local, you kind of still have to click on the password. Otherwise it won't let you move forward, right? So you just click on the password, hit login, and then you should be good to go. You shouldn't have to supply any usernames or passwords in this lab at all. They should all be point and click and easy. So as that's coming in, you got HOV alarm. We're going to expand vCenter here. We're going to expand the cluster called region A01. And then we're going to expand the region A01, or the data center region A01, and then the cluster A01 comp 1. Everybody there? Or further? For those of you that jumped ahead? Good? All right. Logging in. Okay, so virtual machines. So virtual hardware improvements. Oh, another nice thing about the manuals, if you see these little eye charts here that you can't read, you click on them and it expands them out. So it's just a little trick we try to do so you can actually read these. Now, hardware version 20 is where we're at with vSphere 8. A couple of things. You gotta have hardware that supports hardware version 8, right? So if you don't have the hardware, don't move to it, right? Stick with 19, 19's good. 20 is a little bit better, but I don't know how many people are using 256 vCPUs per VM, right? Is anybody here doing that big? No? Okay. Now the one thing I do want to notice, or want you to notice here, is that if you look from like the hardware versions from 15 to 20, you notice that some of the things don't change very often, right? Like the maximum number of logical processors is at like 768. That is all partner and customer driven, right? So we've already tested the 768 on the maximum number of logical processors. So until we have partners or customers telling us they need to go beyond that, we're not going to go out and just spend extra testing cycles on that. But when people need it, let your virtual teams know, right, out in the field, and we can go back to corporate and say, hey, this is something we need. And that should get pushed up that way. But there's a lot of things there that don't change, but then when we need something changed, that could have been for SAP HANA. It could have been for a lot of reasons why we increased that, but somebody needed 256, so that's what we went to. All right, virtual topology. So this is kind of how NUMA works, right? So if you're not familiar with it, so you've got memory DIMMs in the server, you got CPUs, you got cores, and what happens is if you try to assign too many CPUs to a VM, it will cross what they call the NUMA boundaries, right? So if you notice, the DIMMs, they use local access, right? The memory connects, does local access to the CPU. But when you go too far and you cross those NUMA boundaries, now the memory has to go across the channel over and do a remote access to the other memory, right? What that causes is latency. What that latency causes is performance issues, right? So it's very important to know that, hey, we need to set this up correctly. Now in vSphere 8, we've done that. It's called vTopology, and we're going to give you, and we'll go through this on a VM, but what that does is it basically says, hey, you don't have to figure out if you're doing NUMA boundaries. We're going to look at your lower hardware at the vSphere level, and we're going to say, hey, you want a VM with 4 CPUs? We're just going to set up how many CPUs and cores we should do to make NUMA right. So with that said, even though we're doing it for you, we do allow you to make changes to that, right? Because we know everybody wants to go, yeah, that's not what I really want to do, but we do warn you, and we'll go through that and you'll see the warnings and all that. But just because there's a warning there doesn't mean it's a bad thing. It just means that, hey, you should keep an eye on this because it could be a performance issue in the future, right? And as we go through here, there's lots of details on there, like, hey, how should you do this? Is it 4 sockets with 1 core, one socket with 4 cores? There's some details there. We'll go through that. And I've got a nice little spreadsheet that's been around since the ages that will show you kind of make sense of that whole model. Well, the one thing I will notice or mention before we go into the VM and creating it and showing you how that works, does anybody have virtual machines that have, I don't know, 16 CPUs, 32 CPUs, lots of memory, right? I sometimes ask why you went to that many CPUs, but I won't hear it. It's just, most of the time it's either because I could, or because my app owners wanted that many, or we already had 8 and the app owner said, hey, we're not getting enough, we want 16, right? And most people make the mistake of just adding 8 more CPUs and going, sure, cool. But the example that I use that works really well with app owners, because I do work with app owners all the time explaining this, right, is think of it like a restaurant reservation, right? If you go into a restaurant and you have 16 people, right? what happens? You're waiting for a table, right? That's how our CPU scheduler works, right? It's like, hey, I need to use 16, I need a table for 16, right? I need 16 CPU cycles at the same time. So what happens is your VMs on that same box that have 4 or 8, guess what? They come in after you and they go, hey, we're a table of 8. Cool, we're gonna seat you. And then you're sitting here with 16 people going, hey, wait a minute, like they sat down before me, right? So your VMs that actually have more virtual CPUs might be waiting longer to actually use the CPU cycles, right? So sometimes it makes sense to lower that and you'll get better performance lowering the CPUs than raising them. It's kind of an odd thing, but it's all about how we use the CPU cycles in the scheduler. Now the scheduler works really well. It works, you know, we keep enhancing the scheduler to make that not a thing. But at the same time, if you're waiting for 16 CPU cycles and somebody with 4 comes in, they're gonna get those cycles first, right? So we wanna make sure that we right size the VMs to save you performance. Most of the times you can fix that before the app owners come to you. But if they come to you and say, hey, I'm not getting enough CPU, I need more, watch, you might get a little bit more, but you're not getting 8 more cores or 16 more cores more, right? You're just getting a little more and getting them off your back. But you could be causing a problem later down the line, right? Especially as people oversubscribe, then that becomes a bigger and bigger and bigger issue, right? So if anybody needs that conversation to be had with your app owners, I'm more than happy to have it. So I've been doing that a long time, so. All right, so let's go ahead and build a VM. So we're gonna go to ESXi. So let's make sure we're on that guy. And we're gonna right click and we're gonna say new virtual machine. After we do new virtual machine, we're gonna call this vTopology, or call it whatever you want, it's fine. We're not going that far in the labs. vTopology, there we go. We're gonna make sure it's in region A01. Try to keep up with the lab manual. We're gonna put it on ESXi2A, next. We're going to, let's see, select the storage. We're gonna put it on the local ESX host. And we're gonna make sure it's on ESX80 or later. Windows we don't really care about right now because we're not gonna actually start this VM up. I just want you to see how this topology thing works. So we're gonna say next. And let me catch up with the lab guide real quick. Okay, yep, and then we're gonna go to VMware options. When we go to VMware options, we're gonna scroll down all the way to the bottom to CPU topology. And we're gonna change the CPU, I believe, to 8, if I'm not mistaken. Let's see, yep. We are gonna change the CPU, assigned at power on. We're gonna, I'm sorry, what are we looking at here? Did I skip something? Oh, CPUs. Did I miss something? CPU topology, standby. I think I skipped something. Oh, there we go. That's right. We're gonna do assign to power on, scroll down. Yep. Next. What did I miss? Oh, yeah, okay. So we should, oh, that's why. This thing's zoomed in kind of crazy, Peter. I don't know why, but that's why I couldn't find what I was looking for. So we go assigned at power on, and we're gonna scroll down. Cores per socket, it only allowed me to do 2.
When you resized it,
I don't know.
the zoom level on that?
I don't know, yeah.
Yeah, if you go here and go to, get the manual over there for a second.
Oh, yeah. Stand by for 1 second.
We just have to do the zoom level.
Here?
Yeah, the zoom level is probably over 100 right now.
It's driving me insane.
Where is it?
I don't see it.
Scroll down, keep scrolling down, zooms. Yeah.
Ooh, that's too much. There we go, that's probably a little better.
Oh, now do it at 60 because no one will be able to see that on the screen. There,
That's fine. Okay, cool. All right, sorry about that. So we're just getting the zoom level a little bit better so everybody can see. So pull the manual back. What did I miss? So I'm at CPU's 8. Did I do it on the right host? O2A. So does everybody else see 8 there? Sorry? Oh, yeah. That's what I missed. Sorry, thank you. Back up. Oh, was it on the same screen? I just missed it. Got it. I've actually built the lab. I just, I'm going, I can't see anything on this little screen, so it's killing me, so stand by. Next. BTP, next. ESXi, local host storage, compatible with 8, Windows doesn't care. There we go, thank you. That's the step I missed. There we go, 8. So we're changing the CPU to 8. I don't think we changed the memory at all. We're gonna change this number to 10. So make sure that that's at 10 because we don't wanna, you know, as I mentioned, this lab is about 3 terabytes in size. So if we all try to do 90 right now, we're gonna make the S3 bucket scream probably. So we wanna keep that at 10. Then we're gonna go to VMware options. We're gonna scroll down to vCPU. Scroll down a little bit. Now you're gonna say assign to power on. We're gonna force it to 8. So instead of doing you know, you assigning 8 CPUs with 1 core each or whatever, we're just gonna say assign to power on, but now we're gonna force it so I can show you kind of the error messages you're gonna get, right? So I'm gonna force this to say, oh no, I want 8 cores per socket, and it's gonna come up and give you an error, right? And that error is like, hey, this is a manual configuration. Not that it's a bad thing, but just understand that, so this might cause you a problem in the future, right? In my opinion, let us use our best practices to do that. We're looking at the underlying hardware, we know what it's done. If you leave it at assigned at boot on, that way if you ever move that VM, it'll actually readjust it, right? It could change the cores and CPUs based on the hardware you're running on, right? So let it do its thing, but it does have the ability to let you override that. Let's see, then we go to memory, let's see. Oh, assign, yeah. And then what are we doing? We're assigning it. Okay, change NUMA nodes to 1. So we're gonna change the NUMA nodes to 1, and again, it's gonna give me a little error there, right? And it's gonna say, hey, this could cause you an issue, right? So this is basically saying, hey, I want 8 CPUs on a single side, right? So on the single NUMA model. So in theory, what it might wanna do is it might wanna split it across both processors to make it run more efficient, right? It just depends on how the hardware is set up. I'm gonna cancel this because I don't really need to make that change, but I wanted to make sure that you understood that, hey, this is the way you would actually make that adjustment on the V topology. But in most cases, you can probably leave it alone, it's probably fine, but if you need to make those adjustments, you absolutely can. Any questions on that V topology? It's a new thing, so I just want to make sure that we called that out. Because I will tell you, I've had more performance challenges around NUMA than I have had on anything else, right? You know, if you don't set it up right, it's a hard thing to track. Like you can look at it and try to figure it out, but unless you're using something like ARIA operations or something like that, it's a really hard thing to track that you're crossing NUMA boundaries and you're creating latency and lots of things. So always kind of take a look at that. All right, determine the legacy hardware version, right? So we go down to Perfworker 02A, which is down on ESX 01A, you will see Perfworker 02A. So as an example, in this VM, you go to compatibility. Sorry, we're gonna go look at the compatibility at this stage. Stand by. Yep, so you're going to virtual hardware compatibility. Oh yeah, so we're looking at this and we're trying to see what's the compatibility mode, and it looks like it's sitting at 6 right now, right? I can't even scroll down that far. There we go. There we go, 6, right? So we're gonna go ahead and change that to 8. Now, has anybody done a hardware version upgrade at mass scale? Anybody had challenges with it? No? You are yeah, some people have. You're the lucky few if you have not, right? So a couple of things I'm gonna point out here and heed them for what they are, but we'll point them out here in just 2 seconds, right? So let's go ahead and change or upgrade the compatibility. So we're gonna right click the O2A worker and we're gonna say compatibility and we're gonna say upgrade compatibility. That's the message, right? It says, hey, by the way, when you're upgrading the hardware compatibility, you might wanna take a snapshot of the VM, right? There's a reason for that. And I've seen it bite people before, so I wanna just point it out. When you're changing the virtual hardware, you're changing like the motherboard on a server, right? Like, so your operating system may or may not like what the new motherboard is, right? I mean, that's the easiest way to explain it. So always, if you can in production, test dev, cool, run it, let it go. In production, I like to take a snapshot of the VM first. right? It doesn't hurt. I would rather you spend an hour, taking the snapshots of your environment than 10 hours on a support call because it broke something, right? That's a crucial thing that could cost your company millions of dollars. So heed that warning. If you haven't seen problems before, you are one of the lucky ones, right? Not everybody sees problems, but when you're changing the OS and the motherboard, when you're changing the motherboard on an OS, it just doesn't always like it, right? So keep that in mind. That's what this is for. We're going to go ahead and say yes here. Oops, there we go. Yes. We're going to say go to vSphere 8. That's fine. Say OK. Oh, yeah, I went too far. There we go. And we're going to say OK. And now you can go down here and look, and ESXi is all available, right? So the reason that this happened is because the machine is clearly turned off, right? The virtual machine is powered off. So it instantly just goes to 8. Everything's good. I made it look really simple. In a real environment, when the VM is running, it does require a restart in order to make those changes happen, right? So keep that in mind. Restarts are required. So as you're doing things like Patch Tuesday, that's the time you would do those hardware upgrades, right? So just kind of plan them accordingly. Take snapshots, take snapshots, take snapshots. Yeah, just want to put that in your head. Like, it's very important. It'll save you a weekend, I promise you. All right, latency sensitive workloads. So if you look at the high sensitive, requires 100% reservation. So I kind of want to point this out. So with hyperthreading, right, we can actually force applications to have better latency, right? So if you have a low latency application, then we can go this route. I don't recommend this for every VM, because what happens is when we do the hyperthreading, the hyperthreading here, it basically reserves all the CPU and memory for that VM, so there's no overcommitment anymore, right? Like your VM will always have those resources available to it, right? That's how we get and can lower the latency sometimes, because there's no oversubscription or that CPU ready time thing, that waiting for a table kind of thing. There's none of that, but there's a cost to it, right? Most of the time, applications are fine with the CPU scheduler, but keep in mind that if you have a low latency application that has low latency requirements, that this is available to you, right? So we'll go ahead and do that as well with a VM, right? So we'll go create a VM. Back on ESXi02a, we'll go do create a new VM. See if I can hit all the steps this time. I'm gonna say next. Call this VHT, vHyperthreading. Say next. We're going to put it on ESXi02a, next. Put it on local storage, next. I'm getting ahead of myself. A horrible example. I'm so sorry. I should never get ahead of the manual because it'll mess me up. We're going to go ahead and do ESX80 and later. That's next. Windows we don't care about because we're not going to actually boot up the VM. So we're good. We'll just say next. And here's where we're going to change this a little bit, right? So we're going to change the CPU. We're going to hit CPU. We're going to go to the reservation, and we're going to say maximum, right? So we know what the VM's going to do. So we know it has two CPUs because it says it here. We're going to go ahead and change. Go to CPU, and we're going to go to reservation, and we're going to click the arrow and say maximum, right? So that's going to take whatever the maximum of I think this is a 2.1. Probably like a 2.1 gigahertz server. So basically what it's going to do is it's going to double that, right, and take the maximum because it needs 2 CPUs worth of gigahertz, basically. So we're going to say maximum, cool. Next here, and then we're going to go to memory, and we're going to go to, got to minimize that. We're going to go into memory, and we're going to say reserve guest memory. We're going to go in and we're going to minimize that, go in and change the hard disk size to 10. Next. And we're going to hit, sorry, did I miss something? Yeah, I did. No, I got it. All right, cool. Click advanced. Where am I at here? Set latency sensitivity. I missed something here. Change hard disk. Oh, VM options tab. That's what I missed. Cool. Yeah. Now we're going to go to VM options. Sorry about that. We're going to go to VMware options. We're going to go to CPU topology, right? Is that right? Or am I jumping ahead? Advanced latency sensitive. Sorry. Advanced latency sensitive. Latency sensitivity. We can say high with hyperthreading, right? So high with hyperthreading is what your low latency applications would want to use, right? And again, I wouldn't use this for every application. I mean, not that you couldn't, but there's no reservation. I mean, there's no oversubscription at that point. We're going to reserve all that for that application, right? So high, and then we're going to go ahead and hit cancel here because there's no sense in doing this. Yeah, we try to warn you a bunch that it's taking up 100% reservations. Has anybody here used resource pools? Yep. Did you have good luck with resource pools? If you did, you know how to use them, right? Resource pools can be a really great thing. It does add some complexity, but they can be a really great thing. Or if you don't know how to use them, they could be a really bad thing, right? So keep that in mind as well. But this is kind of like reserving the resources for those VMs at a VM level, so it's kind of nice. So you don't necessarily have to do a resource pool that way. You can just do it through the VM. And then we'll go ahead and hit cancel there because we don't need to really do that because we're not testing anything outside of that. Hardware for use. So check your processors on your host. So I think we look at O2A first. You go to summary. Let's see where I'm going here. And you see the processor type here. Actually, where am I at? There we go. So you see your processor type. This is a gold. It's got 2 gigahertz and 8 logical processors. If you go to ESXi, which is right below it, you'll see that it's only it's a gold, but it's only got 4 logical processors. And so keep in mind, like you may have. Does anybody run different servers or server classes in your clusters? Yeah. Okay. Anybody here running multiple hardware vendors in a cluster? Okay. You are? Yeah. Don't ever do that. No, I'm kidding, but really, it's against best practice to run different hardware vendors in a cluster. And the only reason for that, it works. Like, it's just a server, right? Where that will bite you hard is if you have a support ticket and you've got a problem on a VM running on a Dell server, as an example. Not that you would ever have problems with that, but if it was on a Dell server and you had a problem, then is it a Dell problem? Is it an HP problem? Is it a Lenovo problem? Or is it a VMware problem, right? So it will add MTTR, mean times to resolution, to your solution, right? So if you can stay with the same vendor inside of a cluster, highly recommend it. I have seen people do multiple and not have any real issues, but I don't like to point fingers at other people and say that it might be them, it might be them, it might be them. And unfortunately, that's what's going to happen in a support case. And it's not our support fault, right? It might be only happening on the Dell side or the VMware side. Is it a BIOS? Is it firmware? You know, it's just hard for us to troubleshoot that. It makes it adds a level of complexity to this troubleshooting, right? So if you can stay away from that, please do. But in this case, you can have multiple processors and multiple memory and all that, but it's not best practice to run multiple vendors. Here's an example of a couple of servers. This is kind of what you would normally see, like you'd see like an Intel Gold, or you'd see AMD EPYC, 112 logical processor, 128. That's typically what you'd see in an environment, right? But in this case, we have 8 and 4 just because they're virtual ESX hosts, right? So keep that in mind. I think we went through this already, but if you look there, you can see the logical processors, the overview, right? If you go to overview, oh yeah, I'll do overview. So if we go to ESX, what is it, 03? Yep, right click. Oh, I'm sorry, no, we go to configure. We go down to hardware. We go into overview. You can kind of see an overview of the processors. You can see, everything that you want to see, how many gigahertz, is there hyper-threading enabled? Is it not enabled? Things like that. So that's where you can find that data. Yeah, this is an example of physical, right, where you'd see more processors, more logical processors and active. That's just an example of hardware that's legitimately hardware, not just a virtual machine. ESX host. your memory overview, right? So your overview here, you can scroll down and get to memory. You can see all the memory and the how much memory the virtual machines are taking up, if that's helpful to you. Some of this I'm bringing up because it's new to vSphere 8 or it's moved from somewhere else, when, because everyone likes to do that a little bit, right? Like, so as an example, some of the things that I've known in vSphere forever, I'm like, hey, where did that go? And they're like, oh, well, we put that in storage policies. I'm like, oh, okay, well, it's not where I thought it was before, right? So this is one of those examples where now you got a place to go look under the hardware overview. You can see everything. One thing we found in one of our other labs, which is somebody said, hey, I don't see hot add CPU or memory anymore. Like, where did it go? Well, when you add V topology, right, it disables hot add, right? Because we've basically said, hey, we're putting this VM where we think it belongs. You shouldn't have to hot add, right? So just keep that in mind. You won't see that until you disable or go past the V topology, right? Then you can actually check the boxes for hot add CPU and memory, right? So a little trickiness there, I guess, but it's still there. It's just you got to know how to look for it. So that's why we're pointing some of these things out here. Power management policies, you can go down to the bottom. We can edit the power management, and you can say high performance, right? That's going to give you, it basically takes away all your carbon emission savings, because we're not going to ever try to save any of the power. It's not going to be any cheaper to run at the data center, but it will be the most high performing because we might run the fans, we might run the CPUs hotter. There's lots of things we can do at that level. So high performance, you've got low power, you can do custom, but in this case, we'll just do that and say, okay, and just put him in high performance level. It doesn't matter. In one of the other labs, I think it's in the second lab, the 2409-22, I actually go through every one of those in there to tell you what every single one of those means, right? So if you don't get what you need out of this lab, the other two labs are add-on labs that we, again, split up because there was just so much content. So if you don't see it here, it might be in one of the other two labs. Yeah, we can confirm that. Okay, validate your hardware. Very important. As you go to ESXi, please go to the compatibility list before you go to vSphere 8. Make sure that everything's in the compatibility guide. That could cause you some challenges, right? And I'll give you a great example. I have a home lab that I spent some decent money on. And my server is, I bought it used, but it was like 4 processors, 8 cores each. Ran vSphere 7, no problem. Installed vSphere 8, no problems, until I went to run VCF on it, and it tried to install edge nodes. And come to find out, my processors aren't supported on vSphere 8, so it basically doesn't populate, because we don't test it, it doesn't populate all the CPU information in ESX. Still works, but it doesn't populate it. Well, one of those lines is about the pages on the cores on the CPU. And the edge nodes now required to see that little, hey, you have this much size in the CPU. So because of that, I couldn't install the edge node automatically. I had to go do some wizardry to make it work, right? So I just don't want you to get into a position where you go and install stuff, go install vSphere 8 on there and then find out, oh, there's something missing, right? So always go check the compatibility list. That's the real key message there. Now there's a lot of data here, just like the links in the front about all the best practices and things like that. I'm not going to read all of these things to you about recommended best practices or optimal host performance, right? That's for you guys to go back and look at that at a later time, because we would spend all day reading a book of things. Because we want to make sure that we have a jam-packed amount of information so that you don't have performance problems. Again, saving a weekend, that's my goal, right? I want to save a weekend. So anyway, so we have recommended optimal host performance, right? And we talk about RAM, dedicated high-speed network for adapters. We'll go into storage hardware considerations. Well, there's a lot there. iSCSI and NFS storage considerations, NVMe storage considerations. Like, does anybody here run NVMe drives on their servers? I mean, one thing to note, right, that people don't realize is that when you're running that much high speed, it uses more CPU, right? Because it's actually pushing the data, right? So it makes sense, but we don't think about the CPU implications. Just, oh, I changed the storage, it shouldn't change that, right? But as you go to higher speed storage, it does change your CPU allocation. Very minimal, but it's something to consider, especially if you're running your ESX host hotter and hotter and hotter, which everybody seems to want to do nowadays, right? So don't stay safe, just run it hot and get performance problems and waste your weekends, right? So anyway, I'm very conservative when it comes to running your servers hot. I mean, there's a way to do it, and I'm all about overcommitment. I think overcommitment is really smart from a monetary perspective. You know, I mean, I know they're recording the session. You can buy less licenses if you consolidate more, but if you do that, and that's fine, you have to know what to look for when you're overcommitting, right? Like CPU ready time, CPU wait time. There's things that you have to know to look for, because if you overcommit too much, you're just gonna hose yourself, right? So I'd love for people to save money on software and hardware, right? I do. But I also don't want you to be miserable because you're trying to fight this thing and now you can't get more budget to buy more hardware and you really need it because you thought you could get by. So please get us engaged. We'll help you size the environments appropriately. We'll help you try to right size the VMs, right? ARIA operations. Anybody here use ARIA operations? Yeah, some? Okay, cool. I know it's a cost, right? And I'm an SE or an architect, but I will tell you that has saved a ton of people, right? It's in dashboards, the CPU ready time, the CPU wait time. You know, hey, by the way, you've given this SQL Server 16 CPUs and it's using 1. Right? And hey, let's right size it. It might perform better, right? So lots of things that you can get value out of that. And please don't take that as a sales pitch, but I do see that does help with performance a lot. Even if it's not ARIA operations, you should have some type of management that's giving you that data, right? So keep that in mind. Let's see. Network hardware considerations, right? So a lot of people don't realize, I mean, I think people realize it, but you know, I've been at VMware a long time, and I can tell you it's never VMware's fault. It is always storage or networking, right? It's got to be one of those two things, because VMware would never make bad software or be bad, right? So, but and that's kind of kidding, but like all kidding aside, you know, things like storage networking. I've seen a bad route hose us, right? Somebody made a change to a switch, and guess what? Now it's causing latency issues. And that's not the networking's fault, it's the way it's been configured, right? So lots and lots of pieces that you can do there to kind of just, you got to know to look there or you're not going to find your problem, right? So it's just, there's a lot of data here to help you find that challenge that you might have. Okay, so that's kind of the conclusion of Module 1. We still have about 35 minutes or so to run through Module 2. So I'm going to let y'all do that on your own, and we're going to be here to answer questions. But there is one, I got to find it. While we're, you guys can go ahead and start Module 2. I'm going to look for an Excel document in one of the blogs from the old days to kind of show you what NUMA looked like before vTopology, right? So go ahead and get started. When I find it, I'll jump back in and, yep, question. Oh, hold on, he's gonna grab the microphone, sorry. Let me,
How to use ESXtop more efficiently for troubleshooting the performance issue?
Yeah, so everybody heard that. So ESXtop, how do we use ESXtop to more efficiently? That's gonna be in module, or not module 3, but the third lab. It is almost 100% ESXtop, right? Showing you, hey, let's run a load. Let's go look to ESXtop, see what it says. Let's go look at the CPU ready time. It goes through all the things you should be looking at in ESXtop. So that's the ESXi subsystem lab. That's all that lab is. So everybody can kind of see the spreadsheet. So this is what we used to deal with vNUMA, right? And this will tell you how old this document is, but I lived by this thing for a long time to explain it to people. So this is a 2-socket 10-core box with 40 logical cores, right? So if you had that type of a box and you were assigning CPUs to a VM, how should you assign them, right? This is what we used to look at. We'd say, oh, okay, well, if you've got, you know, that, how it's set up, you notice once you go past 10, it's like, okay, you should use 2, right? You should use 2 CPUs so you don't cross that NUMA boundary. So you're using both CPUs and then doing however many cores you needed. Does that make sense? I mean, we talked about NUMA a little bit. So if you had 2 sockets, 10 cores, anything from 1 virtual CPU to 10, you could really do one CPU in the system, and then you would associate however many cores you needed, right? That made sure back in the day that you were never crossing that NUMA boundary, right? Because you were only using one CPU and only the cores off of that CPU, right? If you went past that, so what I've seen customers do is they'll say, oh, I'm going to do one CPU, one virtual CPU and 20 cores, right? And what that does is it causes that to use one CPU and trying to cross the NUMA boundary to use those other cores. And that's where you get performance issues, right? And then you see suboptimal really things like 11 and 13 and 15 because it's going to mess up the NUMA boundaries, right? So this is kind of what we had to do in the past. vTopology fixes this, right? You don't have to look at this and try to figure out what makes sense based on the hardware you're using, especially since a lot of you have large environments that might have, you know, servers scaling from 2 CPUs and 8 cores each to maybe 4 CPUs and, you know, 32 cores each, right? I mean, there's a lot of delta, and you don't want to have to build a VM and go, oh, okay, now I got to look at the hardware, I got to do all these things. vTopology fixes that. So I just like to bring this up because this made it a little bit confusing back in the old days, and this is why people got it wrong, because they didn't understand it. vTopology fixes that for you. Try to use that if you can. If you have to override it, just know that there's some things there. Okay? With that, we are available for questions. Go ahead and go to Module 2 and have fun, and let us know if you have questions. Yes, sir. A question there was if you have an application like a Cisco VoIP or something like that, right, and it has a specific recommendation on the number of CPUs. So a couple of things there. One is I've been at VMware a long time, right? But I used to work for a company that did enterprise software, right? A management company. And I will tell you how I wrote my architecture and my documentation for that software. I better stand up here, sorry. The way I wrote my documentation and my architectures for that was I looked at whatever the newest stuff was hardware-wise, right? Because we didn't really, you know, most customers didn't have VMware back then, right? This was like early 2000s, right? So I would say, oh, what's the latest thing? Oh, it's 2 processors, 8 cores each, or 2 cores each, or whatever it was back then. And I would say, that's what my server requires, right? And so because I knew it would work on less things, I would always give it more because then there's a buffer. I knew 100% it would never have a performance problem because you're running hardware that I never even tested. It's newer. So if you have an application though, that you say, hey, it's got these hard requirements, it has to have it, then you can certainly go into and reserve that space for those, or you can go ahead and say, hey, I'm going to do 2 processors, 16 cores. Most of those vendors will have a hardware requirement for the application, like 2 processors, 16 cores each, or whatever it is. And then sometimes they also, if you ask them and say, what are your virtual requirements? Sometimes they'll say, oh, just do 2 and 4, right? Or something like that. So it just really depends on the vendor, but you can assign that. You just let vTopology do it for you. If they need 16 CPUs, just put 16 CPUs and it will figure out how many sockets and cores it needs. Or you can override it and you can do it yourself, right? So the question was, if you have a cluster with multiple different CPUs, different Intel processors, as an example, in the same Intel family, you know, how do you do that? How do you reserve that? Well, typically there's a couple of things you can do, right? So you can have enhanced vMotion turned on, right, EVC, and that kind of dumbs them all down. I hate to use that term, but it does kind of dumb all the processors down to the lowest common denominator. But just because they have different frequencies, right? If you had to have a certain frequency, like it requires, you know, 2 processors, 2 cores, and 3.1 gigahertz, right? Then I would say your best bet would be, hey, if you have other servers that have less than that, then I would probably try to find the server that has that, and I would try to lock it down on that with using like anti-infinity rules or something like that. That would be my best option for you probably. Because that would guarantee the frequency, right? Oh, I'm sorry.
Yeah, I'm sorry. A lot of them have a reservation, but they don't have a requirement for the frequency.
I'm sorry. You do have a requirement for the frequency?
They don't. That's what I'm trying to
okay.
say. They just say X amount of CPU, but they don't.
Okay.
Yeah.
Yeah, so if that's the case, then you can run it across the entire family, right? If you're using EVC mode, it should be fine. I mean, I hate to say that, but when you're running a cluster that's not in EVC mode, you might not be able to vMotion that VM, right? Like when you're running across families. So you probably should have enhanced vMotion or EVC turned on anyway.
Does VMware actually work with Intel a lot more? Because newer family Intel, even the same family, they are not allowed those vMotion like before. You have to turn on EVC. We're trying to avoid EVC as much as possible, really.
Sure, yeah, so EVC mode, so yes, we do partner with Intel a lot, right? What I would say from a partner with Intel, it's not really a partner with Intel problem per se, right? The problem is that you're using different instruction sets. So if a VM is running on newer hardware, on the newest, latest, greatest Intel processor, and you try to vMotion it to an old processor, it basically says, hey, I'm using different instruction sets. I have to reboot, right? I mean, the VM itself, it's like changing the hardware of a server on the back end without rebooting it. Like, it's just, if you rebooted it, it would work fine. But if not, you kind of have to use EVC. So I would say, if you're choosing different families, then I would say EVC mode is the way to go. If not, otherwise, then I would lock it down to whatever host that you can lock it down to where it can actually move around. Does that make sense?
Do you have any follow-up? You're good?
I know it's not a great answer. I mean, I'd love to say we're working with Intel, but the thing is, when a VM is talking to the CPU at like ring 0, right? It needs to. What, it's the same?
He was talking about it being in the same processor family, but they're different microcodes. So even though it might be Skylake, it might be a different microcode version of Skylake?
Yeah, but EVC wouldn't have different versions of Skylake, would it?
No. No, but if it's within the same family, are you having problems vMotioning it, or is it with...
Sorry.
Yeah, even with CPU, like in the same Skylake, but it's only one version difference. It's like, that's it.
I think you should be able to vMotion if it's in the same family. Like
yeah, before, but now it's like they're getting a lot worse.
Really?
Yeah, every time we refresh hardware, we have to do new cluster and do all this crazy stuff. Migration is a pain.
So I'm in the field a lot, right? And I haven't seen anybody tell me that they're in the same processor family and had problems with vMotion. If that's the problem, there might be a different underlying problem there that's causing that, because you should be able to go from Skylake to Skylake no problem. Where EVC comes in, I mean, you can't use EVC if it's two Skylake versions, because EVC is still Skylake. So I feel like maybe a support issue should be opened up if that's the case, and see what we can come up with. And real quick, please, please, please take surveys. The reason I bring up I'm sorry? Sorry, I can't hear you. Prizes, yeah. There are prizes for taking the surveys. More importantly for me, because I don't get any prizes if you take surveys, but more importantly for me is that we want to make sure that when we do these labs, we're giving you what you're looking for, right? If I totally missed the boat on vSphere performance like introduction, I need to know that, because I need to make it right for you, because this is your conference, your labs. So please feel free to take a survey, good or bad. Please take the surveys. That helps us get it right for you later, okay? Thank you.